Good morning, students. In the last class, we discussed about Ohm's law. So, what is Ohm's law? We said that without changing physical parameters and temperature, current flowing through a conductor is directly proportional to potential difference applied across the ends of the conductor. So, we have taken two conditions that we should not change temperature and physical parameters. And next thing, it is applicable only for conductors because the semiconductors and diodes does not obey Ohm's law. So those make as the limitations of Ohm's law. So what are the limitations of Ohm's law are? First one is what? It is not applicable at high temperature and low temperature. If the temperature is maximum and minimum, it is not applicable. Second thing is, as we already said, that it is applicable only for conductors. And next point is, we said that for the condition of Ohm's law without changing physical parameters, means if physical parameters will changes, it is not applicable. So it is not applicable if physical parameters changes. So these are the limitations of Ohm's law, very important for 2 marks question. So note this is very important for 2 marks. So many times they have asked that write the limitations of Ohm's law. Now in Ohm's law we got one special element or special property of the element called what? R, right? What is R? R is called resistance. So what is resistance is, see, you know that when you connect it to a battery in a conductor, all the charges starts to flow, right? Yes. So all the electrons gains one particular direction, that is from negative to positive. So when all the electrons are moving in one particular direction, there is a probability of these electron may collide with other electrons, right? So there is a collision between electron and electron, or these electrons may collide with metal ions, or these electrons will collide with the walls of the conductor. So what happens? There is some loss of energy. That property or that loss of energy we can compensate in the form of what? Resistance. So it is defined as the property of the material which opposes the flow of charges. So the property by virtue of which the material opposes the flow of charges is called resistance. So we can say that the property of a material by virtue of which opposes the flow of charges is called what, ma? Resistance. Now for example, if you take a small conductor, I am taking an example that here if you take the these are atoms, assume that these are atoms and the small elements of the electrons. So they are moving in random motion. When they gain or when some potential is applied V, they start to move, right? There is a collision between electron with metal ion, or there is a collision with electron or the electron with wall of this one. Now these are the possibilities electron may lose energy. Now if the length of this conductor is increased, what happens? The number of electrons also increases. If the number of free electrons increases, the probability of collision of electrons with other electrons also increases. So we can say that if length increases, the collisions will increase. So we can say that resistance is increases. So resistance is directly proportional to length. Now for example, if you increase area, the electrons gains more space, so they can move in different ways. and the probability of getting collision will be decreases. So we can say that R is inversely proportional to area of cross section. That implies R is directly proportional to L and inversely proportional to A. That implies we can write as R equals to rho L by A. So let us know what is rho first. Here this is the formula for resistance. So R equals to what? Rho L by A. Here very important concept that how on which factors resistance depend. Factors affecting resistance. So factors affecting the resistance, what are the factors it depends? First one, length. It depends on length of the conductor. Next, inversely proportional to area of cross section, and rho. Rho is a proportionality constant which depends upon nature of the material. So it also depends upon nature of the material, and one more quantity that depends is what? Temperature. So that is the basic property, right? We said that temperature changes, Ohm's law will depend, right? So these are the factors on which the resistance will depend, that is length of the conductor, area of cross section, and nature of material. Resistance is directly proportional to length, inversely proportional to area of cross section, and temperature dependence is different for different materials. That we will discuss clearly in the next concept. Now, what is the formula we got for R? R equals to rho L by A. So here rho is proportionality constant called, what we can call that as is resistivity of material. So what is rho here? Rho is called what? Resistivity. Let us know what is resistivity later. Next, SI unit of resistance. So resistance is measured in ohms. So the SI unit of resistance is what ma? Ohm. The symbolic representative of ohm is this one. Okay. So means no need to round up this one. This is the representation of what? Ohm. Next, we are going to write the dimensional formula for resistance. So what is the dimensional formula for resistance? R is equals to what? V by I. Is it right from Ohm's law? R equals to V by I. That equals to what? V, work done per unit charge, Q into A. What is work done? M L square T power minus 2 by charge units AT into A. So finally, what you can write? M L square T ಮೇಲೆ ಬಂದ್ರೆ T power minus 3 A into A square. If you come numerator, A power minus 2. So this is the dimension formula for what? Resistance, and resistance is measured in ohms. Now here one more quantity we learned. What is that? Resistivity. Let us define what is resistivity. Already we said that resistivity is the property of a material which depends on only the nature of the material. So from that, rho is equals to what? RA by L. Is it right? For example, if A equals to 1 meter square and length is equals to 1 meter, A equals to 1 meter square and L is equals to 1 meter, then substituting the above equation, what do you get? Rho is equals to R, right? means what? Resistivity is equals to resistance. When area of cross section is 1 meter square and length is 1 meter. So the same can define as the definition that it is defined as resistance of the material having unit area of cross section and unit length. So when a material having unit area of cross section and unit length, that resistance offered by that material is called what? Resistivity. So resistivity is defined as resistance of the material having unit length and unit area of cross section. So what is resistivity? It is defined as the resistance of the material having unit length and unit area of cross section. Here you should know that it depends on nature of material and temperature. Second thing is, it is independent of dimensions. So we come to know that we have a doubt that, sir, here it depends on area and length, and again you are saying here it is independent of dimensions. See here, we is defining the property of resistivity as the resistance offered by a material of having finite length and finite area of cross section, means unit length and unit area of cross section. For example, I have taken material steel. I want to produce current in that steel. So the resistance offered by it is constant, right? So if I change the dimensions, can the property of steel will changes? No. So it is the inherent property of the material which opposes the flow of charges that remains same, and the resistance will vary for length and area of cross section, but the nature of that material remains same. So it is independent of dimensions and depends on nature of material and temperature. Here let us know about SI unit and dimension formula for this one, same thing. So SI unit is what? We don't know. What is the formula for rho? Rho equals to RA by L. R is measured in, now only we will come to know that, ohm. Area of cross section meter square. Length is measured in meter. So meter cancel, we get ohm meter. So this is the SI unit of what? Resistivity. What about the dimension formula? Simple. Already we have derived the dimension formula for resistance, that is for ohm. What is that formula? ml square t power minus 3 a power minus 2. So same thing we are going to write, ml square t power minus 3 a power minus 2 into meter. Meter is measuring length L, right? So finally resistivity dimension formula is what? L cube t power minus 3 a power minus 2. So this is the dimension formula for resistivity. Here some two quantities will come. Those are, one is conductance, that is represented as G. What is conductance is G is equals to 1 by R. Which opposes the flow of charge is called what? Resistance. Which allows the flow of charge, which allows the charge is called what? Conductance. So the reciprocal of resistance is called conductance. What about the units? Inverse of ohm, right? What is the inverse of ohm? Ohm inverse R reverse MHO, or one more is Siemens. Okay, just the dimension of the reciprocal of resistance. There is one more quantity called conductivity, which is the reciprocal of what? Resistivity. Rho is equals to 1 by sigma, or sigma equals to 1 by rho. The representation of conductivity is what? Sigma. Now, there is one more definition that we will derive later. J is equals to sigma E. From that, sigma is equals to J by E. As we know this one, this is what? Current density, this is electric field. It is defined as ratio of what? J is what? Current density to electric field. SI unit is Siemens meter inverse. So, these are the things, basic definitions that required for derivation of the next concepts. So, we come to know that 4 definitions here in this class. Resistance. What is resistance? The opposition of or the property of a material which opposes the flow of charges. It depends upon 4 factors, that is length of the material, area of cross section, and nature of material, as well as temperature. It directly depends upon length and inversely proportional to area of cross section. So, we are writing the formula as what? R equals to rho L by A, where rho is called proportionality constant called resistivity of the material. What about dimension formula? And we have it. And what is resistivity? It is defined as the resistance of the material having unit length and unit area of cross section. It depends on nature of material and temperature and independent of dimensions. The reciprocal of resistance is called conductance, and the reciprocal of resistivity is called conductivity. So, one more definition we define as, it is defined as the ratio of drift current density per unit electric field. So, this you go through the concepts once clearly. We can discuss in the next class based on resistors, how the resistors connected in series and parallel, and the relations between these things. Clear? Thank you.